Hey guys, how's it going? Mr. Lee again. This is my PowerPoint that I'm just uploading now for your diesel high pressure side components, right? Well, basically, I want you guys to download as always and watch this lecture and download the PowerPoint before class so you can just get primed. This way, we will just discuss the important points and the things that you guys maybe don't understand or need more clarification. Then also we can allocate more class time for more hands-on, and even I can help you with those review questions that I've assigned recently as well. Okay, so let's just get started. So these are the components that are part of your high pressure diesel system, right? Starting with the high pressure pump most obviously, and there are different types of pressure pumps which we will actually get into in more detail. Your fuel rail pressure regulator, right, and this is on the common rail diesel system. If you remember, there's a regulator valve that will return fuel back to the tank or back to through the fuel cooler then the tank, because your high pump, as we know on the CRD system, always supplies an excessive amounts of fuel, excess of what is even required at all times. The fuel rails themselves, or rails in case of a V engine, like for instance like a Duramax, like a V8 diesel, there's two fuel rails, right? And also this includes all the actual metal lines that will attach all the rails to the pump, between the pump and the rail to the injectors. All the high pressure lines obviously are included. Your fuel rail pressure sensor on common rail diesel systems, the fuel rail itself, there will be a high pressure sensor there. The computer uses that information as well to determine the right amount of injection for varying load and engine speeds. Your fuel pump volume control valve, and this is again your main metering unit to the high pump, right, on the common rail diesel system. The fuel pump volume control valve, essentially you feed the pump more fuel, that means you're going to have more output, right? More volume and more pressure. If you don't feed as much, then you have less coming out, right? So that's what the job of the volume control valve, just like GDI, right? Same thing. Finally, the fuel injectors. We will get into the fuel injectors as well. There's different types, obviously solenoid and piezo type, right? Which same as GDI, but we got to talk about mainly the return side of your diesel injector, which was highlighted in one of your Argos, but we'll get into that in a little later. And finally, fuel nozzles. Fuel nozzles are applicable to your injection pump style systems, not the common rail. So if you have like a multi-chamber injection pump or injection pump with fuel distributor, basically you won't have any solenoid or piezo type injectors. You basically just have a nozzle with a little poppet in there. We will talk about those as well. So this first audio PowerPoint that I'm going to go through is we're just going to talk about a few things. We're going to talk about mainly the diesel governor, what that is, and also the multi-plunger injection pump. And then I'll upload separate lectures for your mechanical distributor and your electronic distributor injection pumps, right? Okay, so what is a diesel governor? I don't know, you might have heard of this word before. There is a very, very good Argo that I will do together with you guys in class, which has better animations to explain this further. But in a nutshell, we don't have to get too complicated, because all these functions now are done via your diesel, basically your main diesel control unit, or your engine control unit, your ECU. Everything's done computerized now. But you need to understand the mechanical portion just to understand the earlier mechanical injection pump styles, right? So essentially, what is a governor? The governor, this is a component that was used to regulate fuel delivery for varying engine speeds and load conditions. So it mechanically controlled the amount of fuel, right? And basically depending on engine speeds, engine load. So this was your input from the driver, essentially, right? So if you look at this diagram here, essentially this lever here, okay, this lever will be attached to your driver input, let's say, right? From the gas pedal and whatnot, right? And this lever actuates what this is called the control rack, and it will all make sense once I get into your first type of injection pump. The control rack, let's just say this rod controls the actual injection, right, at all the different pumping elements inside the injection pump. And this will all make sense momentarily. But what the governor essentially does is, over here, this component here rotates with the engine, right? It will rotates with the main drive of the actual injection pump, which will be attached to your crankshaft, right, at half speed. So as these weights spin, centrifugal force will send these weights outwards, which will in turn pull in this piston here, which will change the pivot point of the fulcrum on this actual lever. So essentially, if you remember the basic theory, let's say you have a diesel engine with increasing RPM, right, with no engine load. Let's just say you're sitting there free revving the engine. As RPMs raise on an engine, we need to basically decrease the amount of injection, but also advance the decrease the amount of fuel being injected, right, when there's no load, right? But when there is load, we have to increase the amount of fuel injected. When there is load, there's less centrifugal force. When there's no load, the engine starts to raise in RPM. We need these springs will actually act on this fulcrum, which will allow a decrease in fuel. And when there is load, it will reduce the amount of centrifugal force, which will change the ratio of this fulcrum, allowing for more fuel to be injected. This will all make sense in the next slide, but essentially the main thing you need to know about this is the governor connects to the fuel control rack on the injection pump, and it's also the connection to the accelerator pedal. Okay. It's a lot more simple nowadays. Everything's computer controlled, but these older systems are actually quite intricate and require a lot more. It's a way more detailed explanation because everything's all software based. But essentially, what you need to take away from that is the governor is basically your load and engine demand, right? This is how the pump gets its information in terms of your varying engine speeds and load demand, right? So the first pump we're going to talk about is the multi-plunger injection pump. What is a multi-plunger injection pump? You may or may not have seen this before. These are still used today on most off-road heavy-duty machinery, such as bobcats and like bulldozers and stuff like that. I'm not too familiar with that department, but I know that these pumps are still used in some of those machines. So for decades, the most popular diesel engine fuel injection system was the multiple plunger fuel injection pump. Right? As the name states, it's essentially however many cylinders there are, there will be a plunger in there. So if it was for an inline 6, you'll have 6 plungers. And if you had an 8-cylinder, you'd have 8 plungers, right? Each plunger is per cylinder, per nozzle, right? So though this technology is obsolete in today's modern engines, right, these injection pumps are still used and serviced, especially in classic diesel vehicles, right? These pumps are still used today in off-road heavy-duty machines like I mentioned before. This is an example of one of my favorite cars of all time. This is an old Mercedes 300 SD. You will still see this. If you guys one day work for a Mercedes-Benz dealership, you will see these still today because they just are bulletproof. The engines last forever. These pumps rarely fail, right? So having the knowledge to tackle these older technologies, which are still relevant, can be a huge advantage to your career. Okay. So what is it? A multi-plunger injection pump is basically a fuel pump that uses a piston-like barrel and plunger assemblies that are actuated by a camshaft to pressurize fuel for injection. Okay. Due to the layout of these components, you have the pump followed by the lines coming out of the pump and then going to the nozzles. This type of fuel delivery system is referred to as a PLN, pump line nozzle fuel system. Okay. These pumps utilize a system known as a port helix metering system. If everything will make sense in the following couple slides, and also we're going to go over this in much greater detail in class. But basically, within the case of the injection pump, okay, there are pumping elements which consist of a finely machined barrel fitted with a reciprocating plunger. Okay, I think we actually have a real example that I can show you guys in the lab. If not, I can borrow one from Truck and Coach. It's pretty interesting to see. So the plunger draws in fuel through an inlet port of the barrel, and as the plunger is pressed upwards by the camshaft, fuel is discharged on the top of the plunger under pressure into the nozzles. There are as many pumping elements as there are cylinders of the engine. As in inline 6, you have 6 pumping elements. Okay, so here, this is a video attached that's very, 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 very useful, okay? This is a basic but very clear explanation of how the port helix piston works, right? By changing the effective stroke of the pumping element, the pump can vary the quantity of fuel injected. By changing the orientation of the helix groove, by changing the orientation of the helix groove to the fill and return ports, we can increase or decrease injection quantity, right? So what I need you guys to do is, once you have downloaded this PowerPoint via the course shell, right? Watch this video. Right, watch this video before you proceed in this lecture. Right, make sure you watch this video, and you will see how have a good understanding of what this gentleman is saying in this video, and then all of this, the PowerPoint will make a lot more sense. But if not, we will continue the discussion in class as well. So on truck and automotive applications where the RPMs fluctuate, we would need to use the plunger which uses the lower helix, and this would make sense if you have watched this video, because we need the point of injection to start the point of injection start to remain the constant, meaning the moment this piston goes up, right, as mentioned in this example of the helix, port helix type design piston, you want the point of injection to start at the same time every time the top of the piston passes over the inlet and discharge ports. Okay, the only thing that will change in this type of setup is as your control rack, which is attached to these plungers, the only thing that will change is the point of injection ending, right? It'll start the same, but if you notice, if the discharge port starts to line up with the helix, right, this cut helix here, right, the longer this section is of the piston, you'll see in the video, the longer the section is, the longer the injection timing would last, right? But if it's really, really short, that means as soon as the injection starts, right away, as soon as the discharge port passes into this lower cut region of your helix, all that fuel would bleed through and actually go back to the return, right? So this type of application we would need on like an automotive or basically on a driven vehicle where the RPMs actually fluctuate, right? If you had a diesel engine where, as he mentioned here, a diesel engine that's used for machinery, that's just stationary, that always has the same amount of RPM, then you would want to control the start of injection rather than the start of the end of injection, right? So anyway, we'll go over this in more detail together in class, but I will not watch the video with you with this the presentation because it doesn't work properly. So here's a really good picture, as you can see here. Once you watch this diagram as well, or watch this video, it's only a minute and a half long. It clearly describes how the control rack rotates the plunger within the actual pumping element. Just imagine this rack would be longer, and however many cylinders are on the engine, let's say you have a 6-cylinder with 6 pumping elements, then this rack will be long enough to connect to the 6 drive pinions on all 6 pumping elements, right? So as you accelerate or decelerate, you're just repositioning the plunger within the actual pumping element here. You're just repositioning the plunger to control the amount of fuel being injected at any given time, right? Now, the actual firing order or the injection order in this case, right, would be machined into the actual pump, injection pump camshaft. So below here, there's a camshaft that spins that will push up on this plunger, right? Now, that layout of that camshaft will determine which piston is going to be pumping at which time, right? Because each of these is connected to a cylinder, right? And also the timing would be basically you would time the camshaft to your crank in relation. And they time the camshaft in relation to your crankshaft to determine, so to make sure your injections will fire at the appropriate time, right? In this case, cylinder number 1, if this pumping element was for cylinder number 1, it would be timed for number 1 TDC, right? The moment the cam lobe pushes up on this ram here, okay? Now, yeah, again, please have the PowerPoint downloaded already so you can watch these videos first before following through this lecture. That will be a lot less confusing. And now, so the control rack here, oops, sorry. Sorry guys, just click happy over here. Sorry, we'll quickly cover this before the video is over. I got a 15-minute time limit. This control rack would be attached to the governor, the throttle, and the accelerator pedal, right? So the mechanical advantage that the lever has on this control rack will be controlled by the governor, right, depending on engine RPM, and then the actual governor, the throttle lever, will be connected to your accelerator input. Okay, I hope this helps. Again, this is just a brief overview. We will discuss these in more detail once we reconvene in class. But please, you have to watch this first so that we can have more of a dialogue and like a question-answer type thing in class. All right? Thanks, guys.